what the characteristics of these particles are. And let's see what they are. The first one, let's do a small experiment, okay? Let's take a little beaker. And we have water in the beaker. And what I want you to do is, as you see that beaker, put a spoon inside, right? You look at the level of water. And once you put the spoon inside, what happens to the level of water? It rises a little bit. Makes sense, doesn't it? The spoon occupies some space. Therefore, the water has to go a little bit up, right? Somebody has to make space for the spoon, right? Great. Because spoon also is matter. It has mass and occupies space. Great. Now do something else. Put your finger inside. Yeah, now that you do that as well, you notice that the water level is still going to rise a little bit. But now let's do something interesting, right? Put a few crystals of sugar inside. Yeah. Just drop a spoon of sugar inside and stir for a while. Yeah. If you can keep the water a little hot, it's easier. We'll tell you why that is later. So stir for a while and see what happens. Yeah, you've stirred and after a while you can't see the sugar. Now why that happens in the next chapter. But first of all, the sugar is inside the water. But what happened to the water level? It did not rise, right? It's exactly there. So is sugar not matter? So sugar, does that mean sugar does not occupy space or does not have mass or something like that? We know that's not true, right? We've taken sugar, it seems to be occupying some space. So what is happening here? That's right. As you stick with that question, think about it, right? The only possibility or a very, very likely possibility here is that there is something in between these water molecules, which we can call space. And let's see what really it is. Let's take this water. And if we were to, like in the movie, Honey, I Shrunk My Kids, right? If we were to shrink ourselves or equivalently zoom this out, right? What you're going to see is that as you notice the molecules of hydrogen with oxygen, with hydrogen, if you don't already know that, that's pretty much what water is, right? Two hydrogens stuck to an oxygen. And if you go inside, you notice that they're not all stuck together. Each of it is stuck to each other, but in between there is so much space. Enough space for a miniature me to walk around and to stay in. So what does that mean? Even though what you look at around you, which seems solid, right? Things that appear to be solid, things that our mind smudges over is solid. There are spaces in between them. And it is here, as you can see, the sugar molecules come in, stick. So what's really happening? The sugar does occupy space, but it occupies the space in between these molecules of water. Makes a lot of sense, doesn't it? These are the advantages of being able to shrink ourselves down. And notice what matter is really made up of, because what we see on the large scale is not what the behavior is as you go deep inside. Great. So what's the first characteristic we've observed? Or the first characteristic we've observed? That matter has space in between it, even though it doesn't seem like it on the large scale. Great. Now what else can we find out? Now is all this matter just standing there, static? You look at water, right? It looks pretty calm. A placid lake, right? On a very boring evening, looks perfectly calm. You drop a stone into it, it beautifully starts rippling away. It is it's the calmest sight in the world. But do you think that if you go inside, all the molecules of water themselves, right? Are they just sitting there calm and not moving around at all? Each molecule is just exactly where it is. No movement. If you think that, what we want you to do is play with something right now. Right? Take a little beaker again and drop, say, a drop of ink into it so that we can see what's happening, right? Put a little drop of ink. If you don't have one, go get one. Put a drop of ink and notice what happens, right? You drop the ink and it starts at a particular point and it should just remain there, right? But you know that that's not what happens. Watch what's going to happen. It's going to take a while sometimes, yeah? But pretty much in some time, the entire water is going to be colored. So how did the ink that started off at a particular point on the surface go everywhere? I mean, this had to happen through some mechanism, right? There is some motion between, because if the water was as solid and as still as it seems to be, then this would not have happened, right? Even if you take some potassium permanganate crystals and put them inside, because they also have color, you can notice this. Because in a while, they begin to start going everywhere. Even if you're really lazy to do this, you know that if you light an incense stick in one corner of the room, right? You can smell it in the other corner of the room really, really quickly. Now, how is this made possible? If the molecules that make up what's around us are not moving. If the molecules of water were not moving, how would this ink have been carried between them to other places? Right? It's a good indication that all that looks calm is not really calm. It's actually moving around. It is moving around. And that's the second observation we're making about matter, which is, first one, it has space between it. Second one, it's continuously moving. It's moving around, even though it might not seem like that. And later on, you'll realize that's exactly what we mean by temperature. Yeah. We usually think of temperature as the heat that we feel. But the heat that we feel is actually the amount of kinetic energy, as we can call it, right? Movement, yeah? You will learn, if you've not already learned it, that movement is associated with the kind of energy called kinetic energy. Kinetic meaning motion. So because of the fact that a body is moving, it has some energy. That is exactly what we mean by temperature. Great. So two things. Has space, keeps moving around. Third, and probably the last one for now, is that the question is, all these hydrogen and oxygen and all together, right? HOH, and then they are like around. That's what you call water. Now that we made two observations about them, the next question is, do none of these water molecules really care about each other? Right? Do all these particles of matter are they completely indifferent to their neighbors? Do they like not talk to each other? They don't like, they neither like them nor dislike them. They just exist as if the other doesn't exist. Is there no relationship between them? Now that's a question, right? If that is true, let's ask this question. If that is true, right? If you were to drop water up or try to throw water around, you would see that water kind of comes together in little lumps, and we call them, water molecules, or I don't know what, water bubbles or something like that, right? You throw it almost forms a round shape, right? Spherical shape. Now, why it forms a spherical shape is again one of the questions you'll find out as you get curious. But you throw it around, it starts lumping together. If they had no interaction with each other, why would they lump with each other? Right? They would just be glowing around. Each water molecule separate and start flying away, right? So there's something keeping them together. At least seems like that, right? Forget water. Take something as simple as a chair, or I give you a little box and you try to separate the box, right? You try to break that. You need to break that box. You need to apply some force to break that box. Give you a chalk. It takes some force to break that chalk. Which means that whenever you see particles, whenever you see matter and you see particles, there seems to be something that's holding them together. Now, on that side note, I'm going to ask you one more question, right? You've all had paper. You've played with paper, even if you're not written on it. If you were to try and tear paper, it's going to tear pretty randomly, right? Now, the question I'm going to ask you, but not answer, is this. But somehow, if you make a line in that paper, right, and press it really hard and then tear it, it tears perfectly, right? Now, that's a question for you to think about. But even without that, the question really here is, why does it require some force to tear them apart, right? You could just go do a little bit and then just come apart, right? So something's holding them together. And that's our third and final observation, which is that these particles attract each other. And that's what's keeping them together. We can apply some force and break them apart, but does not mean that there is no attracting force. There is. So the three things that we've learned is that there is space, that they are moving around, and that they attract each other. And that's our summary of the characteristics of the particles that we see around us. So now we've seen that matter is made up of particles. They're really small. We also saw some characteristics. 1, they have space between them. 2, they keep moving. And 3, they attract each other.
Friends, subscribe our channels for next video. Please like our video. Thank you.